This meeting is being recorded.
I'm sorry to disturb you. సెకండ్ లింక్ పంపించాను అంటే వాళ్ళు లెక్చర్ ఫస్ట్ లింక్ కంప్లీట్ అయిపోయింది 40 minutes తర్వాత ఇంకొక లింక్ క్లిక్ చేస్తే ఎంటర్ అవ్వచ్చు అనమాట. కొంచెం జెనిస్ అని ఫోన్లో ఉన్న ఇప్పుడు పంపించిన సెకండ్ లింక్ యూజ్ చేసి క్లాస్ అటెండ్ అవ్వమని చెప్తున్నాను. నేను వెయిట్ చేస్తున్నాను. ఫోన్ ఇస్తే జెనిసా చూస్తుంది ఆ లింక్. సారీ టు డిస్టర్బ్ యూ అంటే ఉంటాను. థ్యాంక్ యూ. థ్యాంక్ యూ.
Sir, 1 minute.
Ah, Janissa, welcome to the class. I could
Sir, I
not
didn't know
see
there
you.
was a second class, sir.
Ah, can you please put on the camera, Janissa?
Yes, sir, 1 minute.
Yes. Janissa, could you are you in front of the yes? Thank you, Janissa. Yeah, I really appreciate you. What to say? It's not so easy to be dedicated to, listen us for such long hours. I really appreciate your patience. Yeah, not so easy. Yeah, reading, listening is not so easy. While I was in China, Janissa, we used to have a beautiful Chinese teacher. She used to be very well prepared, and weekly, hardly we used to have two classes. Each class will go for 1.5 hour. After 1.5 hour means 90 minutes. After yeah, each 45 minutes we used to have a. After 40 minutes we used to have a break, and then in 5 more minutes, 10 more minutes we used to gather, and we will have another. We'll continue the session. The teacher's name is Mrs. Cindy, and I asked the teacher, Chinese language appears to be very difficult. Appears to be very difficult to me. So what should I do to master Chinese language? Because the characters are running into hundreds. How can I learn?
So
Like
if you
that,
are
I asked.
you can
The
expect it.
Chinese teacher said,
I
the
feel
Chinese
I'm
teacher,
so good. I feel I'm quite adjusted to the city now, and
yeah, the Chinese teacher, Mrs. Cindy, has said, listen, listen. The more you listen, the more you get tuned, your mind gets tuned to the accent, then understanding will become easy. So we have to listen. In China, Janissa, like our house of prayer, there used to be a beautiful church by name Minhang Evangelical Church. They are so loving. They received me like their own family members, and one of my colleagues in my lab, by name Chong Chong Yong, took me to the church. Uh, Tomorrow happens to be the Chinese New Year's Day, like January 1st, the English New Year's Day. Chinese celebrate the New Year's Day on 29th January. This year it falls on 29th. It also depends on uh, other aspects also. Basically, the Chinese New Year this year is on 29th, and uh, in church, we used to say, greet each other on Chinese New Year as Xinyan Kuaila. Xinyan Kuaila. Xin, Nian, Kuaila. Xin means new. Neon means Nian. Neon means year. Kuaila means good. Wish you happy. Kuaila, happy. Xinyan Kuaila. This is taught to me by my Chinese teacher. So I'm teaching you because I was taught, no? Xinyan Kuaila. Happy New Year in Chinese. Tomorrow there is a Chinese New Year. It's used to be celebrated in a very grand way. If I were to be in China, My Chinese supervisor used to give me a big parcel with so much of milk powder, meat, oil, sweets, whatnot. He's a generous person. Yeah, Chinese are very hospitable, very generous. They love Indians very much. And let us pray that there be mutual friendship between India and China, and both nations prosper. Coming back to our subject, we are in colligative properties. The second colligative property is the elevation in boiling point. The boiling point has to elevate, has to increase, has to be enhanced by the addition of solute to a solvent. Compared to the solvent, the solution, compared to the pure solvent, the solution will have increased boiling point, as you can see here. Boiling point is, basically related to atmosphere, at 1 atmosphere. Okay. You see, per se, this is the boiling point of pure solvent, the temperature at 1 atmosphere pressure. Okay. The temperature corresponding to 1 atmosphere pressure. If you plot vapor pressure versus temperature for solvent, it is like this, almost linear. For solution, it is like this, and you can see that the vapor pressure of solution is lower than that of the vapor pressure of solvent. Okay, then here you see this is the boiling temperature. X-axis is temperature. The temperature is increasing in the right hand direction, and the pure solvent boiling point is per se TB naught. Whenever there is 0, it is called, it represents pure chemical, pure solvent. Okay, then here if you draw a vertical line, if you draw a vertical line that touches the x-axis, that is temperature, this is called the boiling point temperature of solution. Okay, delta TB is proportional to m, small m. Small m is molality. Delta TB is equal to kbm, where kb is molar elevation constant. Okay, this equation you should never forget. Repeat with me, Janissa. Delta TB is equal to
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 kb
KB
into m.
into M.
Delta TB is, whenever you see delta, it is change, it is difference. Emma, it is the difference. Okay, delta TB is TB minus TB naught. Because TB is higher, TB naught is lower. Okay. TB naught. TB naught is for pure solvent, TB is for solution. Because solution has a higher boiling point than that of the pure solvent. Delta TB is equal to TB minus TB naught is proportional to KB. KB is a constant value. Okay, sometimes you will be asked to calculate the molar elevation constant by giving the value of molality of the solution and elevation in boiling point. Okay, sometimes you will be asked to calculate the, it's very problematic. My battery is going down. Let us see how best we can complete. Okay, now let us solve one problem, Mama. To go deeper into this, you see, delta TB is equal to KB into M. M can be expressed as molarity is moles of solute in 1000 grams of solvent, a kilogram of solvent. If W2 is the molecular weight of solute and W2 is the weight of the solute, M2 is the molecular weight of the solute, molality can be expressed as molality is equal to moles of solute divided by weight of solvent in liters, in kilograms, 1000 grams. Weight of solvent in 1000 grams or kg. Okay, so molality is equal to W2 by M2 divided by W1 into 1000. If we rearrange this equation, what will we get is 1000 into W2 divided by M2 into M1. I told you, Janissa, M2, the term 2 is for solute. The term 1 is for solvent. I think I'm taxing you too much, Amma. Are you tired, Janissa? Yes.
Sir,
Ah,
around 11:30 can the class end, sir?
yeah, we'll stop, Amma. I know very well. I'm very sorry to tax you more. And Janissa, I fully understand, but try to give me time every day. Emma, 10 to at least 10:40. Okay? Like this, we will complete other chapters also. I need some time. Every night, 10 to 10:40, I'll be in touch with you. Okay, now I'll stop in few more minutes, maybe 11:30. Okay? Then you can take rest. I am very sure that you are tired. So delta TB is equal to M molality into Kb. Likewise, delta TF, if you can see here, this is the depression in freezing point. As you can see here, even in the third colligative property, depression in freezing point, y-axis is the vapor pressure, temperature is the x-axis. What will happen is, this is the freezing point temperature of pure solvent, TF naught. F means freezing temperature. Okay, when solute is added, the solvent becomes solution and the freezing point temperature is reduced, TF. TF naught is the freezing point temperature of pure solvent. When you add solute, what will happen? The freezing point decreases. That is why it is called depression in freezing point. So the depression in freezing point again is proportional to molality. Delta TB is proportional to molality. Likewise, delta TF is also proportional to molality. Pi, osmotic pressure, is proportional to C. C means concentration, or pi is proportional to M, molarity, or pi can be written as M R T. What is R? R is universal gas constant and T is temperature. So basically osmotic pressure is proportional to molarity. Emma. So when you know the molarity, when you know the temperature of the solution, you can always find the osmotic pressure, because osmotic pressure as well as reverse osmosis process have many practical applications. What is osmosis? Osmosis only deals with flow of solvent and not solute. Okay, whenever you hear the term osmosis, what should come to your mind is solvent. Osmosis always deals with the flow of solvent. The flow of solvent from, okay, dilute solution to concentrated solution. Okay, the solvent tends to move through the semi-permeable membrane from low concentrated region to high concentrated region, diluting the solution. That is what is called the phenomena of osmosis. The excess pressure that need to be applied on the solution to prevent the flow of solvent into the solution, that is what is called osmotic pressure. The pressure that need to be reverting the phenomena of osmosis, I'll show you. Let us go one by one. You see, Amma, this is the osmosis that I am talking. The blue color solution, what you see is a solvent, and this is the thistle funnel containing a solution. The dark blue is the solution, and you have here a semi-permeable membrane, because the solvent has always a tendency to move from lower concentration region to higher concentration region and dilute the higher concentration region. As a result, the level in the thistle funnel increases. And so pi is given by H rho g or HdG. reverse osmosis also we can see. Reverse osmosis is a phenomena. Okay, the excess pressure that need to be applied to prevent the flow of solvent into the solution is called osmotic pressure. This is what is called a semi-permeable membrane. This is the pure solvent. This is the solution. When we apply excess pressure, that is what is called pi, osmotic pressure, the solvent flow through the semi-permeable membrane into the solution will be hindered, stopped. Okay, then we also have something called reverse osmosis. Reverse osmosis is when the pressure applied is greater than the osmotic pressure. What will happen is from the concentrated region, solvent will flow through the semi-permeable region into a region of lower concentration. That is exactly the reverse of osmosis. And reverse osmosis, we know we have at home reverse osmosis based water purifiers and all. And based on osmosis and osmotic pressure, we have some problems. Based on elevation in boiling point and depression in freezing point, we have some problems. I have clearly indicated and marked some formulae. I'm sending this edited version of Unit 1. This completes Unit 1. And we will also go through the material that was given in Velamal College for each of the chapters. So far, I did not receive the material for organic chemistry that you can share. Okay, ma. When Jerome sir gives, you can share. At this moment, I close the meeting, ma. Please take rest, and tomorrow 10 o'clock night, I will wait for you to join the meeting wherever you are. Okay, ma? I wish you safe travel and wish you success. Pray, pray, pray for success. Prayer has infinite possibilities. Prayer gives victory. May God bless you. Emma, thank you. I'm ending the meeting.